This is question 3. Assume that alpha is in between 0 and pi over 2. Cosine of alpha plus pi over 6 equals to 4 over 5. Find the smallest positive integer r such that this inequality holds. This is cosine alpha plus pi over 6, and this is sine of 2 alpha plus pi over 12. We need to find a relationship between these two angles. So I'll let theta to be equal to alpha plus pi over 6. Since alpha is less than pi over 2 and the cosine of alpha plus pi over 6 equals to 4 over 5, this angle theta is on the first quadrant. So we know that cosine 2 theta equals to 2 cosine squared theta minus 1. And in this case, it is equals to 4 over 5 squared minus 1. So this is 16, 32 minus 25 over 25. That is 7 over 25. Not only theta in the first quadrant, cosine 2 theta is positive. It will mean that 2 theta also lies in the first quadrant. And this suggests that this is 2 theta and 7, 25. Using Pythagoras theorem, 7, 25, this will be 24. So cosine 2 theta equals to 7 over 25 implies that sine 2 theta equals to 24 over 25. Sine of 2 alpha plus pi over 12 will be equal to sine of 2 alpha plus pi over 3 minus pi over 4. And 2 alpha plus pi over 3 is equals to 2 theta. So this is sine 2 theta minus pi over 4. So this is sine 2 theta cosine pi over 4 minus cos 2 theta sine pi over 4. This is equal to 24 over 25. Pi over 4 is 1 over root 2. And cosine is 7 over 25, 1 over root 2. This is actually equal to 17 over 25, 1 over root 2. Let's call this as j. So j is actually equal to 100 times this number. 100 times 17 over 25, 1 over root 2. Cancel off, this is 4. Cancel off, you have 2 square root 2. So this is equal to 34 square root 2. Square root 2 is about 1.414. And this is about 48.36. After calculation, we know that j is about 48.036. So the smallest positive integer r is 49. So 49 is the answer for question 3.